Adjusting the settings. When you perform measurements on a source, it's good to adjust your settings so that they match what you're measuring on or what you're looking for. In this case, I have a broadband source. For measurement on a broadband source, I would recommend using low resolution and high sensitivity. High sensitivity offers the benefit of higher optical gain on the detectors in compensation for a slower update rate. For apodization, I will select none, as apodization is not really necessary for a broadband source. If you're looking at narrowband features of a spectrum, such as the water absorption lines, you should go with high resolution. The sensitivity mode determines the update rate. Low sensitivity gives a higher update rate of a spectrum. High sensitivity gives a lower update rate. On the other hand, does a low sensitivity mode not allow a very high gain of the detectors, meaning that if you have a very low input power into the instrument, you will need to go with a high sensitivity setting. High sensitivity also gives more samples per reference wavelength, meaning we get a better signal to noise for a broadband source. The apodization for broadband sources, you can go with no apodization, or hand apodization if there are narrowband features of your spectrum. If we look into the interferogram, you see that for a very broadband source, most of the information of the spectrum is located near the center of the interferogram. The high frequency components of the spectrum are located on the outer edges of the interferogram, and the low frequency components are located in the center. So if we're only interested in the low frequency components, we can remove high frequency components and high frequency noise by cutting the interferogram. So if we go to Setup an interferogram, there's an option to cut the interferogram. Choosing a smaller value would cut the interferogram to a shorter distance, and the spectrum will have a smoother appearance, but also removing some of the high frequency components, for example, the water absorption lines here. So if you know that the source you're performing your measurements on, or whatever the filter or whatever you're measuring on, does not contain any high frequency components that you're interested in, you can go ahead and cut the interferogram to remove some high frequency noise.